Okay, so we finished that 8.7, and hopefully you did a nice job on that section. And the way they presented it, they had a lot of the problems. You had a greatest common factor that you had to take out before you did the problem. Then it was a difference of squares or a perfect square trinomial. But you needed to first take that GCF out. Well, this section 8 is all about that. 8.8, factor polynomials completely. And we talked about that Wednesday. When you factor something completely, you're doing it so nothing else can be factored. So you've got to look at your answer and make sure it's factored completely, that all the factors cannot be factored anymore. And that means you always start by looking for the greatest common factor. If you can pull out that greatest common factor, and then you look at the factor that remains, you see if it's one of your special forms and see if that can be factored. And then you have to factor that. Okay, now there's one special type of factoring we haven't done yet that I'm going to teach you today. And to start with, I'm going to give you a couple problems that's going to come up with this new method. Take a look at the first problem here. X times x minus 3 plus 2 times x minus 3. Now that's not factored. That's a sum of factors. We need to write it as a product. So the first thing you have to do is look for a greatest common factor. Only here, what's different is that the greatest common factor happens to be a binomial. So take a look at what you have in each of these expressions. You've got an x minus 3 here and an x minus 3 here. That's the common factor. That's the greatest common factor, x minus 3. So that factors out, and you write x minus 3, and then you write the remaining factors. When you pull it out of this, you're left with this x. So that's going to be our x. When you pull it out of this one, you're left with the plus 2. And so here we have it. Now this sum has been written as a product. And that's what factoring means, to write as a product. And so now we have factored that expression. We saw the greatest common factor was that binomial. And we ended up with this product of 2 binomials. And we know it's factored completely because neither of these can be factored anymore. Okay, so with that one in mind, let's look at this next one. This next one has a little twist to it. So take a look at this and take a look at this, and you're asking what's the greatest common factor? And again, you see it's a binomial. X plus 3 is common. So you put that out and write x plus 3. And then you go back and you write what's left. X squared and then minus 4. So you get x squared minus 4. And now you've factored it. It's written as a product, but you have to ask, is it factored completely? Is every one of these things factored completely? And what is it that you recognize? You should recognize the x squared minus 4. That is one of those difference of squares. And that factor. And so what you have to do then is write the x plus 3 and now factor the x squared minus 4. And that factors, we know, into x plus 2 times x minus 2. And now we're done. We have 3 factors in this problem. So that's the whole thing about factoring completely. You're not done right here. It's factored, it's written as a product, but it's not completely done until you factor this. Okay, now this next type, you have 4 terms that you're going to deal with. You've been factoring 3 terms, trinomials, in the other section. You've had to do trinomials. Now you have 4 terms, and you have a special method called grouping to factor this. Now, again, the first thing you should look for here is a greatest common factor, and you can see that there is none. There's nothing that comes out of those. And so now we're going to use the method of grouping. And so what we do is we group the first 2 terms together. And then you group the last 2 terms together, and you have that plus in between. So it's not a product, it's not been factored. We're just grouping the first 2 and the last 2. And now what we do is take the first 2 and factor it. And you can see you have x cubed plus 2x squared. The x squared is the greatest common factor. So you take an x squared out, you're going to be left with an x plus a 2. And that factors those 2 things. And then you look at 3x plus 6, and you know you can take a 3 out. And that leaves you with an x plus 2. And so now we have this. Okay? And now we look at this expression, and it's similar to the ones we've done up here. You've got an x plus 2 and an x plus 2 common. And so you take out the x plus 2, and then you get left with this x squared plus this 3. And now we have it written as a product. And nothing else here can be factored. So that's the method called grouping. It's 4 terms, and you group the first 2 in parentheses and the last 2 in parentheses. Then you factor each of them, and you end up with this common binomial factor that factors out and leaves you with this other factor. And we have it. All right, let's do another one. Let's do this one. Again, there's no GCF here. And so we group the first 2 with parentheses and group the second 2 with parentheses. We take the first 2, and again, you look for the GCF of these 2 terms, and it's x squared. and that leaves you with an x plus a 5. And then plus 2x plus 10, 2 comes out and leaves you with x plus 5. And now you look at this and you see that x plus 5 is common. And so the x plus 5 comes out, and then it leaves you with the x squared plus 2. And there it is. Can we see that? Okay. That's the method of grouping. All right, now there's one last problem down here. This one's a little bit different. This one you have to do something special to get this. Again, it has 4 terms and there's no GCF out of the 4. So we group the first 2 in parentheses like that. Now we have an issue here. It's minus 4x minus 24. Now, if I group by putting parentheses here, and with this minus in front, it would now be minus 4x plus 24, and then I've changed the problem. And you can't change the problem. It's supposed to be a minus 4x minus 24. So whenever you have a minus here and you do your grouping, you have to take this sign and make it the opposite. Now it would be minus 4x minus 24. So we had to make that minus into a plus. That only happens when you group with a negative. And now we take the first 2, and again, what are we going to take out? The x squared, and it's going to leave us with the x plus 6. Then we have the minus, and then 4x plus 24, you take a 4 out, and you leave yourself with x plus 6. And so we get that. And then now we look and we see x plus 6. And so we take the x plus 6 and leave ourselves with this x squared minus this 4. And now we get this expression. And now again, we have to ask, are we done? We've written it as a product, but it's not completely factored because of x squared minus 4. And so now you're going to have to say equals the x plus 6. And then you have to factor the x squared minus 4 as a difference of squares. And that gives you x plus 2 times x minus 2. And now we have 3 factors that do not factor anymore. Okay? All right. So that's a special process called factoring by grouping. That's the last new thing you're going to learn. Okay, and then we've got a few more problems. I've got 4 more for you. And this is all about factoring completely. Factoring completely. Now, these all have 3 terms to them. So you're not doing any grouping here. You only group when there's 4 terms. So what we want to do with these is factor them completely. And again, the first step is to look for a greatest common factor. You factor that out, then you look at what you have left and you see if that can be factored, and you have to factor it. So in this first problem, we see a 3, a 21, and a 30. So we know a 3 comes out. And so that leaves you with x squared plus 7x plus 10. And so far, we have factored this into this product. But now you have to say, is it factored completely? Or can this trinomial be factored? And this is one that has starting with a 1x squared. So you want two numbers that multiply to 10 and add to 7. And that, of course, is 5 and 2. And it's got to be plus and plus. So we then get this. So we took out the greatest common factor of 3, and it left us with a quadratic trinomial that we knew how to factor. We learned how to factor those from section 5, and we end up getting this. And now we are factored completely. So it's similar to what you did in section 7. You took out your GCF. Only in section 7, you were left with a difference of squares or a perfect square trinomial. Here, you're left with just a regular trinomial, and it factored into these two binomials. Okay, next one up here. 4x squared, 12x, and a minus 40. 4, 12, and 40. 4 comes out. Leaves you with x squared plus 3x minus 10. And now you look at this trinomial, starts with a 1, but it's got a minus 10. So you want two numbers that multiply to 10 and differ by 3. And that would be 5 and 2. So we know we're going to get x and x, and we're going to get 5 and 2. And now you know, since it's a minus 10, it's either plus minus or minus plus. You just have to do trial and error, and we want to come up with a plus 3x. It better be plus minus. That gives you plus 5, and a minus 2 gives you your plus 3. And that gives you your minus 10. And so there's the answer. So all we're doing is taking out that greatest common factor and leaving ourselves with trinomials now that you know how to factor. And then you have to factor. Okay, let's do this one down here. We have a 10, a 25, and a 15. So it looks like we want a 5. And then that would leave us with 2x squared plus 5x plus 3. Okay. And so now we have to factor this one. This one starts with a 2 now, doesn't start with the 1. So that was the trial and error method I taught you, where you knew it had to be two binomials, and if it's 2x squared, it's got to be a 2x and an x. And then if the last number's a 3, it's got to either be a 1 and a 3 or a 3 and a 1. And it's a positive 3, says the signs are the same. And if the middle's a plus, it's got to be plus and plus. And so now you just check 1 and 3, or you check 3 and 1. If we tried a 1 here and a 3 here, that would give us 6 plus 1, which is 7. So 1 and 3 doesn't work. So we try 3 and 1. And now you get 2x, and 3x is 5x. And there's your plus 3. So we get 2x plus 3 times x plus 1 times the 5. And that's the method I taught you in section 6. When you have a number here that's not a 1, you do trial and error with this last number until you find the right combination. Okay, and the last one, we have a 6, a 28, and a 16. So what does it look like here? It looks like a 2 maybe. I think it's going to be a 2, and that would leave us with 3x squared minus 14x, and then a plus 8. And yep, this doesn't have anything common now. Okay, and so now we have the 2, and now we have the parentheses. 3x squared means a 3x and an x. A plus 8 says it's either plus plus or minus minus. You look at the middle sign as a minus. So it's got to be minus minus. And so now we do trial and error. We check 8. And with 8, you're going to have 1 and 8, or 8 and 1. You're going to have 2 and 4, or 4 and 2. Those are the possibilities. And so we have to check them out. So we can try 1 and 8 and see that 1 and 8 would give you 24, and 1 is 25. So that's no good. 1 and 8 doesn't work, so you try 8 and 1. That gives you 3 and 8. Minus and minus would give you minus 11. So 1 and 8 and 8 and 1 doesn't work. So now we check 2 and 4 and 4 and 2. If we check 2 and 4, we get minus 12 minus 2 is minus 14. So we found it. Trial and error. And so we get 2 times 3x minus 2 times the x minus 4. All right? That is what you're doing in section 8. You've got an assignment tonight, 1 to 22, all of them. Then you've got an assignment Monday and an assignment Tuesday in the book in section 8. Wednesday, you have 2 Delta math assignments on this. And then Thursday and Friday next week, you have chapter review and chapter test. And then the following Monday, you take your test. So all of next week is just going to be learning section 8 and reviewing. So we're not going to have to meet. So there is no Zoom class next week for you guys. All right, it's just a matter of you doing the work and making sure you do the entire homework problems and look at what you're doing and make sure you learn what you're doing in section 8. And then do the 2 review assignments and make sure you're ready for the test. This is your last grade for this semester, your last major grade. We still have, I think, one or two other quizzes after this. Okay? Does that make sense? Let me get you going here a second.